Hello everyone. So today's class is about Apple reaction, which is the name of reaction. So the Apple reaction is a SN2 type reaction, which is similar to mixed noble reaction. So in this, with the usage of tetrahydrocarbons with triphenyl phosphate reagents, groups like OH and NH2, polar groups, OH and NH2 groups will be eliminated and invert with the stereochemical inversion it's going to substitute. Okay, that is what the main character of the SN2. So here stereochemistry is going to reverse. So if you can say this is the above the plane and the halogen that is attacking will be the below the plane. Okay, so this is what the characteristics. So whatever the groups, if you take NH2 the above the plane and treated with carbon tetrachloride and triphenyl phosphate. This is the reagent system of the Apple reaction. So whatever the halogen that you are taking will be replaced in presence of the NH2. So it is going to become here with the stereochemical inversion. Okay. So if you can see the mechanism. So reaction is going to generate apple salt. Okay, apple salt, that is what this is about the apple salt. So it is dehydrating in nature for some reaction, and this halogen, this carbon ion can act as a nucleophile. Okay, so major reactivity is the nucleophilic addition and reactive carbon center. Okay, that is what this, wherever the alcohol or amine group are present. Okay, so initiation will be with the triphenyl phosphate, which is going to abstract the halogen from the carbon tetrachloride or carbon tetrahalide, so that it is going to form phosphinium ion. Okay, so as well as is going to generate carbon ion. Okay, so because of the three withdrawing groups, this carbon ion is very stable. So it's going to react with the next partner, that is starting material. So as it is a nucleophilic in character and little basic in character, so it's going to abstract the proton which is attached to OH and NH2. Because of the abstraction of the proton, this is going to form oxide ion. If it is a nitrogen, it's going to form nitride ion in minus. Okay, and this oxide ion again is going to attack on the phosphonium ion. Okay, and as the OP bond is very much feasible to form, and it is very much stable if it is forming P double bond. Okay, phosphine. Okay, so the reaction will driven in this way because of the P double bond formation. Okay, so OP bond is going to form, and that will be again broken into the phosphonium. Okay, phosphonium oxide. Okay, so as the byproduct is going to left, so it's going to generate a carbocation system where the OH and NH2 groups are added. Okay, so here carbocation system will be going to generate. In the meanwhile, whatever the halogen that left from the carbon tetrahalide is going to attack in the nucleophilic substitution bimolecular way. So anti-attack will be there. So as the SN2 reaction is a non-intermediate generating process or single concerted reaction, so it will not generate carbocation. So it will directly attack on the carbon which is attached to the alcohol. So this bond will be going to break and X minus will be going to attack. So finally you are going to get a stereochemically inverted product. Okay, that is what the key feature of this Apple reaction. Okay, so reagent system is triphenyl phosphate and carbon tetrachloride. Okay, so attacking species is carbon trihalide anion. Okay, so elimination of the oxygen will be supported by the triphenyl phosphine cation. Okay, so byproduct will be triphenyl phosphine oxide. Okay, TPP. It is called TPPO. So this is what the bulk. Okay. So if you can see examples. So this is one of the example where anomeric carbon of the sugar molecule is replaced with the triphenyl phosphine and carbon tetrabromide CbR4. Okay. So to results inverted system, inverted chiral center. Okay, with the bromine. Okay. So the main application for the Apel reaction is to synthesize oxolyins, oxazones and thiazones. These are heterocyclic 5-member rings. Okay, so 5-member rings. If it is oxolylin, it is having oxygen. If it is aza, it is going to have nitrogen. So the combination of oxo and aza 5-member rings and 6-member rings, as well as sulfur and nitrogen 5-member rings. Okay, so how they are going to generate means here I have given one specific example for that. So this is what the salt, Apel salt generation. Okay, and if it is acid, it's going to abstract the proton of this, then attack of the triphenyl phosphine phosphonium cation. Okay, so this is attacked onto the cation, okay, phosphonium ion, and resulting into the elimination of triphenyl phosphonium oxide. But during this, if you use any amines, okay, if you use any amines, so for example this is the amine, okay, amine system, so that will be going to attack as a nucleophile to replace this. Okay, so by this it is going to form a amine attached to carbonyl system, amide system with alcohol. So if this alcohol is present, it is going to attack onto the carbonyl system. Okay, so resulting into the formation of 5-member ring. Okay, so this is what oxazolene. Okay, a specific example of Apel reaction. Okay, so one more application for this is conversion of a this is what 7-member ring system. Okay, of the just a minute. So this is nitrogen attached to heterocyclic 7-membered system. Okay, so this is called benzodiazepine ring. Okay, so it is also in this we going to demonstrate the dehydrating nature of the Apel salt. Okay, dehydrating nature of the Apel salt. So during the formation of this diazepine ring, so there is a dehydrating reaction, okay, which is catalyzed by the salt of the Apel. Okay, Apel salt. Okay, so anyhow the reagent system is going to generate the carbon trihalide anion and triphenyl phosphonate cation. Okay, so initially it will be going to attack the nitrogen lone pair as a nucleophile will attack on the carbonyl in presence of triethylamine. Triethylamine will act as a activating reagent for the amines. Okay, so that it's going to enhance the nucleophilic activity of the nitrogen. Okay, so after the attacking of the nitrogen, it's going to form an oxide bond. Okay, so this oxide is unstable, and this is going to abstract the proton of the nitrogen, where it shows the nucleophilic activity of the nitrogen to attack on the carbon, so that it can stabilize this nitrogen. Okay, so resulting we are going to form a 5-member ring with 2 nitrogen. Okay, so again abstraction of the proton, it will convert into the OH. Okay, now this Apel salt have this trichlorocarbon ion will abstract the proton of the nitrogen, so that it will drive the dehydration reaction. So H2O will be going to eliminate, okay, by the abstraction of proton, and it's going to this bond is going to move into the CN double bond and the OH will be eliminated, so that water will be eliminated to form the final product. Okay, so in the book it is a printing mistake where nitrogen is missed. Okay, we must take care of that. Okay, so this is about the Apple reaction. If any doubts, please comment, or you can post by the WhatsApp. Okay, thank you.